This week we are going to be solving different types of equations. We're going to be solving exponential and log equations. But in today's video we are going to focus just on solving exponential equations. So exponential equations are equations in which variable expressions occur as the exponents. So you're going to see in all of the equations that you solve today, the x that you're looking for is up in the exponent. So there's two different types of exponential equations, and they each require a different method to solve. So the first group of problems we're going to look at are problems that we're going to solve using the exponential property of equality. So when you have two exponential expressions that are set equal to each other, what we can do is follow these steps to basically solve for the exponent, which is x. So if the bases are the same, right? So if you have an exponent, a base with an exponent equaling another base with another exponent, if those bases are the same, then all you have to do is set your exponents equal to each other and solve. If the bases are not the same, right, you might need to rewrite one or both sides of the equation using the same base, and then set the new exponent equal to each other. And then we're going to continue solving for x. So in example 1, right, I can solve using this first step here. The bases are the same. 5 to some power equals 5 to another power. Well, if 5 to something equals 5 to something else, then what this just means is my exponents have to also be equal. So I can just right away set x equaling to 2x plus 1, and I can solve. So if I subtract 2x from each side, I get negative 1x is equal to 1. Divide by negative 1, and x equals negative 1. Right, so because the bases were the same, I could automatically just set my two exponents equal to each other and solve. Now in number 2, the bases are not the same, so I'm going to go to step 2. All right, so what my goal is to kind of make it look like problem 1. Can I rewrite each side so that they have the same base and kind of play around with the exponents to make them match? So if you look, I have 7 to the 3x equals 49 to the 4x minus 1. Well, 7 and 49 don't match. However, 49 is 7 to the second power. So I can rewrite this side over here so that I do have a 7 as a base. Then I could set those exponents equal. So I don't need to do anything with the side that's 7 to the 3x. But I am going to rewrite 49 as 7 to the second power. So I'm not changing anything about the equation, I'm just changing the way it looks. But you can't forget that there already was a 4x minus 1 up there. So when you rewrite your new equation, and you rewrite this number as a base and a power, you're going to take that new power and multiply it to what was already there. All right? Because what we really have happening is 49 is 7 to the second power, and that was all raised to the 4x minus 1. And if you remember, a power to a power, we multiply 2 times 4x minus 1. Okay, so whatever your new exponent is here, make sure it gets multiplied to the expression that was at the top. So now my problem kind of looks like number 1. 7 to some power equals 7 to another power. So what that means is my exponents are equal. So we rewrote both sides using the same base. Now we're going to set the new exponents equal to each other and solve. So now I can set 3x equal to 2 times 4x minus 1. And again, you want to be careful. It's 2 times the entire thing. So not just 2 times 4x, it's 2 times 4x and minus 1, so you want to distribute. So I get 3x is equal to 8x minus 1. All right, I'll subtract 8x. 3 minus 8 is negative 5x, which equals negative 1. And then if I divide by negative 5, I get x equaling negative 1 divided by negative 5. I'll just keep that as 1/5. Okay. And in my last example that follows these steps, okay, I can tell right now 9 to the 2x and 27 to the x minus 1, they do not have the same base. And in this problem, I only needed to rewrite the one side because I had a 7 and I could rewrite 49 as 7 squared. In this case, we are going to rewrite both sides of the equation because 9 to some power won't give me 27, or 27 to some power won't give me 9. But I do know that they each have a common base of 3. 9 is 3 squared. 27 is 3 to the third, right? So if I rewrite 9 to the 2x as 3 to the second, all to the 2x, then my left side now becomes 3 to the 2 times 2x, right? Because 3 squared is 9. And 27 I'm going to rewrite as 3 to the third, but if that's all to the x minus 1, just like over here, I'm going to rewrite that as 3 to the third, but I'm going to multiply that to all of x minus 1. Okay, so 9 became 3 squared, 27 became 3 to the third. Again, now that I have the same base, 3 and 3, I can just set their exponents equal to each other. 2 times 2x equals 3 times x minus 1. So 2 times 2x is 4x. Make sure you distribute. Okay, 3 times x is 3x minus 3. If I subtract 3x from each side, I get x equaling negative 3. Okay? So just be careful when you are rewriting at this point that you multiply the new exponent with the original exponent. Do not take that exponent to the next exponent. Remember, power to power means you multiply. Okay, so if you are able to rewrite each side in an equation so that they have the same base, do it, and then set both of those exponents equal to each other. In the second types of problems we're going to solve, we are not going to be able to rewrite each side as an exponential equation. So if you kind of look at example 4 here, 9 to the x equals 35. Well, there is no number that if I raise it to an exponent gives me 9, and there's no number if I raise it to an exponent that gives me 35. So there's no possible way for me to turn this equation into like the first 3 that we did. So that's when we're going to use a logarithm to solve. So last week I had you just introduced to logs. We kind of talked about how it's another way to rewrite an exponential expression or equation, and we're going to use that today because I can rewrite all of these in log form. That helps get the x out of the exponent, and then we can solve for x. So sometimes we're not able to write each side as an exponential equation. If that's the case, then we're going to follow these steps. Your first step is to isolate the exponential term with the variable. So get whatever term has the exponent by itself. Then you're going to rewrite your equation into log form. So just remember, if you had b to the x equals y, writing this in log form would be the same as saying log base b of the other side equals the exponent, which is x. If you do this correctly, when you rewrite your exponential equation into log form, the x, or the variable you're solving for, should be outside of the log, and it should be on the opposite side of the log. So it should be like the log of something equals wherever your x at is. If you don't write it correctly and your x ends up back in the log, then you rewrote it incorrectly. And if necessary, you're going to continue to solve the equation. So in number 4, I have 9 to the x equals 35. We already talked about how we can't rewrite 9 and 35 as common bases with exponents. So isolate the exponential term with the variable. Well, 9 to the x is by itself. Do not divide by 9. Don't do anything like that. I'm going to go to step 2, and I'm going to take this and rewrite it in log form. So if I rewrite this equation in log form, that would be log base 9 of the other side, which is 35, equals my exponent. Okay, so my x is equal to log base 9 of 35. Now, in your practice on Schoology, some of the problems might leave your answer like this. Some of them will take this and turn it into a decimal. So I uploaded a document on Schoology that shows you the different ways of how to find or put these logs into your calculator, or maybe if you don't have a calculator that does that, like a website that you could do that. So in your graphing calculator, okay, if you have a calculator like this, if you go to math, the math key, right, and I scroll all the way down to option A, it says log base. Okay, so if I hit enter, I want to type log base 9 of 35, and I get approximately 1.618. We're usually going to round to like the nearest hundredth, so 2 decimal places. So I would say x is approximately 1.62. Okay. All right. In number 5, okay, I have 54 equals 4 to the 4x plus 2. So there's a lot more going on in the exponent up here, but the 4x and the 2 are up in the exponent. So you don't want to subtract 2, you don't want to divide by 4. The term with the exponent is actually by itself. So I'm just going to go ahead and rewrite this into log form. So rewriting this in log form would be log with the base of 4 of the other side, which is 54, equals the exponent. Now the exponent was this whole thing, 4x plus 2. So over here it was just x, but here all of 4x plus 2 comes down. So you can see my x is now out of the exponent, and what I need to know is what's log 4 of 54. So in my calculator, I'm going to type in math key. I'm going to go down to option A, which is log base 4 of 54. And hit enter, and that's about 2.877, so I'm going to say, well, that's about 2.88, okay, and that equals 4x plus 2, and I'm just going to keep solving this. So 2.88, I'm going to subtract 2 from each side, minus 2, that's about 0.88, and that equals 4x. My last step is now I can divide by 4, and I get x being approximately 0.22. Okay, so sometimes when you get your exponent out of the exponent, when you get x out of the exponent, there's more going on. So that's where like step 3 would come in, where you have to continue solving the equation. Okay. Looking at number 6, I have 7 to the 3x plus 9 equals 20. So here's my term with the exponent, the 7 to the 3x. I am now going to use step 1 up here, which was to isolate the exponential term. So because this plus 9 was out back, it was not up in the exponent, I'm going to subtract 9. So I have 7 to the 3x is equal to 11. All right, so here I did have to use step 1. I had to isolate my variable, my expression with the exponent in the, with x in the exponent. All right, and now it's been isolated, so I'm going to go to step 2, which is rewrite this into log form. So this would become log base 7 of the other side equals 3x. All right, so I need to know what is log base 7 of 11. So the math key, I'm going to go down to option A, and log base 7 of 11 is equaling about 1.23, and that equals 3x. And my final step for solving is I'm going to take 1.23 and I'm going to divide it by 3, and I get about 0.41. So a lot of decimals in these problems, so just be careful when you're selecting your options, your answer choices on Schoology, if this is a multiple choice question, that you're really making sure to match up your decimals to the correct answer choice. Okay. And one more example, solving exponential functions. I have 3e to the 2x plus 2 equals 92. So I've kind of got a little bit more going on here. This is the term that has the exponent, the e, just the e to the 2x. So I need to get rid of the 2 and the 3 out front. So just like you were solving a normal equation, the first thing you want to do is subtract 2. So I have 3 e to the 2x is equal to 92 minus 2 is 90. Now, don't rewrite this in log form. Get the e to the 2x by itself first. So to get rid of 3, that's connected by multiplication. I'm going to divide each side by 3. So those cancel, and I get e to the 2x is equal to 90 divided by 3 is 30. Okay, and now the term with the exponent is isolated. All right, so now I can rewrite this into log form. So this would be log with a base e of the other side, which is 30, and that equals 2x. But what you want to remember from last week is that log with a base e, do you remember that's one of those special logs? So log with a base e is really ln of 30. So I don't need to write log base e. This is ln of 30 equals 2x. Okay, and if I wanted to solve for x, I would divide by 2. Right, so I'm going to kind of go over here. So I'm going to kind of write this two ways because I think there's a problem in your Schoology practice where it kind of shows you the two different ways you could write your answer. So the first way I could write my answer is I could say, well, x equals the ln of 30, natural log of 30, divided by 2. Right, that is what the answer is to this problem. The other way is to actually just give me the decimal answer. So at this point, what I could do is just type in the natural log of 30, and that you can just use the ln button. So I'll do that again in case you didn't see that. Here's just the ln button. So I can just type in ln of 30, which is 3.401. So let's say you got here, it was 2x equals 3.401. And then to keep solving, you would just divide by 2. So if I divide by 2 here, I get about 1.70. Okay, so here's my two options for an answer. Kind of just depends on how the Schoology practice question is going to give it to you. ln of 30 divided by 2 is the answer to this problem, which also represents about 1.70 as a decimal. So again, if you don't have the log base, if you don't have this option in your math menu, log base e, option A, please look at your document that I posted on Schoology that shows you the different ways of typing in a log base, whether that's in your calculator, there's two different ways to do that, or a website that will help you just type in the log base to also get these decimals.